When American engineers began designing the structure that would become the Quonset hut in 1941, they had almost no time, no fully defined requirements, and a military that had only one request: build something that could be shipped anywhere, built by anyone, and survive absolutely everything. War was expanding at a frightening pace. The U.S. Navy Bureau of Yards and Docks needed an all-purpose building that could be sent to remote islands, put up by untrained soldiers, and endure the harshest environmental conditions that World War II could unleash. Howling storms in the Pacific, bomb blasts from strafing aircraft, blistering tropical heat, corrosive salt air, thick muddy jungles, freezing Arctic bases, and everything in between. The engineers looked at this impossible list of demands, realized they had less than 2 months to deliver a working prototype, and started sketching. Their inspiration came from something old: the British Nissen hut of World War I. It was a simple half-cylinder made of corrugated metal, cheap and quick to build. But its weaknesses were obvious: poor ventilation, limited interior customization, rusting issues, and difficulty in mass shipping. The Americans needed something better. They needed something that could be standardized, stacked, crated, transported on ships, shoved out of cargo planes, dragged through the jungle, carried by hand, hammered together with minimal tools, and still withstand an incoming storm that could rip trees out of the soil. The engineering team at George A. Fuller Company took the challenge personally. They didn't want a shelter that merely survived war, they wanted one that would dominate it. The first design choice they made was the famous curved shape. At first glance, it looked like a simple half-barrel. But to engineers, this curve was a small miracle. Flat-walled buildings fight the wind, curved buildings glide with it. The arch distributes loads evenly across the ribs, so instead of one weak point failing, the stress flows throughout the shape like water across stone. Hurricanes could slam into the side, but the wind would rush over the curve rather than smashing it inward. Snow wouldn't pile on top, it would slide off. Rain would scatter instead of pool. An arch is one of the strongest structural forms humanity has ever used. Romans built arches 2,000 years ago that still stand today. Engineers realized that if an enemy bomb exploded nearby, the curved shell would absorb and redirect shockwaves instead of collapsing. This wasn't just architecture, it was battlefield physics. Corrugated steel was the next stroke of genius. Corrugation, folded ridges running down the length of a metal sheet, makes the material dramatically stronger without making it heavier. Smooth steel bends easily. Corrugated steel resists bending by distributing force along the ridges. Every explosive wave, every pounding rainstorm, every falling branch from the jungle canopy was dampened by those repeating ridges. American foundries could mass-produce corrugated sheets quickly, and they were light enough to be carried by a few men. The design team chose galvanized steel to resist rust, critical in the salty Pacific air where unprotected metal would rot in months. Engineers didn't just want these huts to work during war. They wanted them to last long after the first troops marched inside. But steel alone wasn't enough. The interior needed a skeleton, something strong, standardized, and easy to assemble. They chose steel T-ribs, arched frames bolted to a wooden base platform. This meant that even if the outer panels were damaged, the frame still stood. Replacement sheets could be tacked on in minutes. But the frames were more than structure, they were the secret to surviving windstorms. Each arch acted as a rigid rib. When connected in a continuous loop, the hut became one giant spring system. In a storm, it bent but didn't break. Engineers tested it against simulated winds that would tear apart traditional buildings. They watched with satisfaction as the hut refused to buckle. One of the most overlooked but genius components was the floor. Soldiers needed something elevated, dry, and stable. Engineers designed wooden floors built on joists that could rest on uneven terrain. If the jungle floor was muddy or sloped, troops leveled it with blocks, sandbags, or stones. The hut didn't need a concrete foundation, just a patch of land and some muscle. The floor panels were modular, you could replace one without touching the rest. If termites ate the wood, you swapped it. If floods damaged it, you rebuilt only what you needed. The U.S. military valued adaptability, and engineers built that philosophy into every part of the hut. Ventilation was a major challenge. Soldiers stationed in the South Pacific were dying from heat exhaustion, malaria, and infections due to the unrelenting humidity. The first prototypes were suffocating ovens. Engineers realized that metal walls absorbed and retained heat. Inside, temperatures soared. They needed a solution that required no electricity and minimal materials. They introduced the ridge vent, a continuous opening along the top of the hut that let hot air escape. Then they added louvered end vents to suck in cool air from the outside. The structure acted like a natural chimney. The hotter the air inside, the faster it rose and exited. To prevent rain from dripping in during storms, the vent was covered with an overhanging hood that shielded it from downpour while still allowing airflow. This was one of the most essential improvements. Without it, soldiers in the tropics would have suffered inside a metal sweatbox. Insulation came next. Engineers experimented with several materials but settled on a composite made from pressed fiberboard and later a combination involving insulation blankets. The insulation panels were attached between the ribs, and suddenly the huts were not just structures, they were livable environments. Soldiers could sleep, operate radio stations, run field hospitals, and store ammunition without worrying about temperature fluctuations damaging supplies or harming personnel. In Arctic bases, additional insulation layers kept the biting cold at bay. In tropical posts, the reflective interior coating reduced the risk of heatstroke. The hut didn't just shelter troops from bullets, it protected them from nature. Every improvement had to pass one test. Could an untrained soldier assemble it? The engineers simplified the design ruthlessly. Nuts and bolts were standardized. Panels were pre-curved. Everything fit into crates that could be stacked inside a truck, submarine, or cargo ship. Instructions were printed in diagrams instead of complicated text. They wanted a squad of men with minimal tools, hammers, wrenches, and muscle, to finish construction in a single day. Many did it in less than 6 hours. Some soldiers joked that building a Quonset hut was easier than pitching a tent. Engineers smiled when they heard that. Their design goal was quiet victory, a building so intuitive that no one realized how much analysis and math went into making it effortless. The first units shipped to Trinidad. Engineers watched how they behaved in tropical storms and intense humidity. They took notes. They improved drainage grooves. They updated insulation materials. They redesigned end walls for faster assembly. Then the huts went to the Pacific. Soldiers dragged them through jungle mud, carried crates through knee-deep water, and hammered them together while mosquitoes buzzed like angry engines. The huts stood tall through monsoon rains that flattened native structures. They survived cyclones that ripped the tops off palm trees. They shrugged off debris from nearby explosions. If a bomb dropped too close, the hut might dent or lose panels, but the main ribs stayed standing. Troops could repair the damage and be sleeping inside the same night. Engineers didn't predict one unexpected effect. The huts boosted morale. Soldiers arriving at desolate island bases often saw rows of Quonset huts already assembled like a small town, orderly, familiar, almost cozy. They weren't just shelters, they were miniature communities. Mess halls, chapels, barber shops, supply depots, hospitals, dormitories, radar stations, even small theaters all sprang up inside these curved shells. On islands where everything smelled of wet earth, diesel, and fear, the huts offered soldiers a dry cot, a warm meal, a chance to rest. Some veterans remembered the huts with surprising fondness. They symbolized stability in chaos. The huts also played critical strategic roles. At airstrips across the Pacific, aircraft maintenance crews used modified Quonset huts to shelter planes from sun and rain. Communications teams set up radio posts inside sound-dampened versions. Medical corps built fully equipped field hospitals, complete with surgical bays, sterilization rooms, and recovery wards. In Europe, Quonset huts became command posts for generals planning major offensives. They were quick to build, difficult to destroy, and easy to replace. In war, logistics is victory, and the huts were logistical brilliance made tangible. As the war ended, millions of square feet of Quonset hut space stood across the world. Many believed they'd be torn down and forgotten once peace returned. Instead, the opposite happened. Surplus huts were shipped back to the United States, sold to civilians for cheap. They became homes, offices, diners, churches, machine shops, garages, and barns. College campuses receiving waves of returning veterans used rows of Quonset huts as emergency classroom housing, launching the educations of thousands under the GI Bill. The huts became icons of post-war America, symbols of ingenuity, resourcefulness, and the ability to turn military design into civilian utility. What made them so enduring wasn't just affordability. It was the engineering. A design perfected for war happened to be perfect for peace. Farmers discovered the huts resisted storms better than traditional barns. Mechanics appreciated that the curved roof gave them more vertical space. Families who lived in insulated huts found them surprisingly comfortable. Architects even reinvented them for modern housing, proving that good engineering never dies, it simply evolves. But the real heart of the story remains the engineering team that shaped the original design under wartime pressure. They never intended to create a cultural icon. They were simply trying to solve a problem. Many of the decisions they made were not flashy or celebrated. They chose standardized bolts because replacements would be easier. They sloped the end walls slightly to reduce wind drag. They included a slight overhang at the base to prevent water from seeping under the floor. They coated the steel with zinc to delay corrosion. None of these decisions were dramatic. But layer by layer, small choices combined into an indestructible whole. There was also an invisible triumph buried in the design: adaptability. Engineers didn't know where the huts would be used, so they built a structure that could be altered on the fly. End walls could be wood, steel, or replaced entirely with open bays. Windows could be added, removed, shifted, or expanded. Doors could be placed at either end. Internal partitions could create offices, bedrooms, surgery rooms, or ammunition storage. Some huts were raised on stilts in swampy terrain. Others were half buried in Arctic snowbanks for insulation. One structure, thousands of uses. That level of flexibility was revolutionary. And perhaps the most remarkable aspect was this: the huts did exactly what they were built to do. They survived storms that shredded palm groves. They kept soldiers alive in suffocating jungles. They endured bomb blasts, monsoons, and winter gales. They proved that with the right design, even the simplest materials could become life-saving architecture. The engineering brilliance of the Quonset hut wasn't in one dramatic idea but in dozens of small, elegant solutions woven together into a structure that was almost unbreakable. Engineers designed for every nightmare scenario they could imagine, and those they couldn't. They created something humble yet heroic, a shelter that protected over 1 million service members across the globe. To this day, Quonset huts stand on Pacific islands, barely rusted, still structurally sound. Some house families, some store fishing equipment, some serve as workshops, others sit abandoned, half covered in vines, silent witnesses to the war they survived. But their curved silhouettes remain instantly recognizable, a reminder that great engineering doesn't always look glamorous. Sometimes it looks like a simple arch of corrugated steel. What began as an emergency wartime project became one of the most iconic, resilient, and influential architectural forms of the 20th century. The Quonset hut wasn't designed to win battles directly. It didn't fire bullets or drop bombs. But it supported everything and everyone who did. Engineers gave soldiers a home in the world's most inhospitable places. They gave commanders the infrastructure needed to coordinate campaigns. They gave medics a place to save lives. They gave crews shelter to repair aircraft that would fly missions the next morning. The hut was always there, quiet, dependable, unshakable. In war histories, generals and battles receive the spotlight. But behind every victory lies the invisible machinery of engineering. The Quonset hut is one of those unsung heroes, a reminder that sometimes the most powerful weapon is a roof that doesn't collapse, a wall that doesn't buckle, and a design that refuses to fail. It is ironic, perhaps poetic, that a structure built for destruction became a symbol of continuity and community in the decades after the war. Farmers still store grain in them. Artists convert them into studios. Veterans look at them and feel a rush of memory. Architects admire their purity. Engineers study them as a masterclass in functional design. The huts helped win a war and then helped build a peace. Engineers designed Quonset huts to survive storms, bombs, and jungle heat. They succeeded beyond all expectation. And in doing so, they proved that the simplest ideas, when executed with precision, creativity, and brilliance, can outlast the chaos that created them.